Smart India Hackathon 2025. Our problem statement is FloatChat, AI-powered conversational interface for ARGO ocean data discovery and visualization. Our proposed solution includes a conversational AI system for querying ARGO float data using natural language. What makes our concept unique is that, unlike existing ARGO platforms which provide raw datasets and static dashboards requiring technical expertise, our solution makes ocean data conversational, intelligent, and accessible. Instead of downloading raw data files and writing code, users can simply ask in natural language, what are the temperature changes in Indian Ocean over the past 5 years, and get clearly interactive charts and maps instantly. In order to implement this idea, our technical stack includes the following technologies: data pipeline and storage. We used Argo data repository, .NET CDF files, and Python XArray library for data ingestion, and Apache Airflow for automation. We used PostGIS for geospatial information storage. For AI backend, we used Fast API, Google Gemini API in order to convert user-generated textual queries to SQL queries. For front-end and dashboards, we use Streamlit, Plotly for dashboard creation, interactive chart design, PostgreSQL for live data ingestion, React and White for interactive and feasible front-end creation. Deployment infrastructure, we use Docker and Docker Compose for containerization, Apache Airflow for automation on top of Docker. This is a technical stack. Feasibility and viability. Our solution is highly market viable because the demand for simplified ocean data spans governments, industries, researchers, and education. Governments need it for climate monitoring and disaster preparedness, while industries like fishing needs it for cost effectiveness, and researchers and students need it for educational understanding, and global organizations need it for collaboration purposes. The strategies that we used are data preprocessing plus FIAS indexing for speed and accuracy, fine-tuned LLMs with domain-specific training data, and data preprocessing which can handle large datasets as well using Python, RAG grounding with metadata in order to reduce LLM hallucinations. Impact and benefits. This problem statement and proposed solution have a wide range of benefits. Majorly, it's a scalability, disaster preparedness, and policy support and collaboration. Other than that, economic, environmental, education, and innovation benefits are also there. This project builds trust and shared goals among nations through data transparency. It also empowers learners by giving real-time insights. Research and references. For references, we used the dataset from ARGO Global Data Repository directly from government website and NetCDF documentation in order to understand the NetCDF file ingestion and pre-processing. Our core technical stack includes for front-end prototype creation Streamlit and React, backend Fast API, database PostgreSQL with PostGIS for geospatial information, AI or RAG we use Gemini API, and further planning to use Hugging Face. Containerization is done using Docker and Docker Compose. For visualization, we use Plotly, Leaflet, and Cesium tools. So here is the prototype of our problem statement, ARGO data dashboard. You can ask any question, ocean related question. For example, what's the average temperature near a latitude and longitude? We can run this query. We can get the answer value as 14.3380. This is happening because the user asked a English language query is converted into a SQL format. This is done using Gemini API key, which acts as an LLM backend for us. And this SQL format is given to us PostgreSQL database, which has our Argo data profiles, and the result is displayed in this format.
Some of the predefined dashboards include temperature versus depth, salinity distribution, temperature versus depth heat map, TS diagram, and the profile locations. The blue dots indicate different locations where the ocean data is collected from. But now, yearly analysis, we can even get analysis of yearly data 2018, 2019, 2020. Compare different years of data, temperature versus depth per year, salinity distribution per year. This is done using Streamlit. At the same time, I have developed another React-based app which is more like interactive. You can ask any question here, or for example, if there are sample questions to try out. And there's also an option of voice input. There's a data upload page as well, where you can upload various CSV files and then write expose, which has an overall overview of different profiles, chart queries, average temperature, and graphs. There is another page that we have added just to make people more aware about our Indian Ocean. Like, it has all Indian Ocean related info like monsoon dynamics, marine biodiversity, thermal properties, island ecosystems, and major Indian Ocean related locations. And we are also planning to include an AI visualization where people can ask to generate very Indian Ocean related scenes and AI would generate it for them. Thank you.